Hi, hello there, and welcome back to Steamer with Steve. Today we're going to go through how percentage increases and decreases work. So let's jump on in. Now, this is super important when we're trying to work out the cost price and then the sales price, because we can either increase or we can decrease by a certain percentage amount. And there's a little trick that I'm going to show you here, which will hopefully make the whole process a bit easier for you. So to start the lesson intention, what we're going to do, we're going to look at increasing an amount by a fixed percent. We're then going to decrease an amount by a fixed percent. And then we're going to use a triangle, which will help us work out these different amounts, which is a nice little hack, which hopefully will help you. But before we start, just pause the video and have a go at this little warm up. Cool. So for the first one, you should have worked out that was a half. The next one was also a half. The next one was then equal to 1. And then 4 out of 100 is the same as 4%. This is then 5%. And then 9 out of 90 is 10%. So why do we use percentages? Well, it's easy to compare two scores together. So if you had two tests, for example, and on the first one you got 27, and then on the next one you got 35, which one did you do better in? And it's impossible to work out, because was the first one out of 50? Was it out of 100? We don't know what it was out of, so it doesn't give us context. Whereas by using percentages, it makes it a lot easier. If I then said there was a fraction, so you got 27 out of 30 on the first one, and then 35 out of 50 for the second one, you're sort of leaning towards the second one already, but you don't know by how much better it was, because you got 35, right? Then if we change it to a percent, you can see really clearly that the first one's actually really better, because you got 27 compared to 30, which is only 90%. Whereas the second one, you got 70%. So by saying it as a percent, it's a lot easier for our brains to sort of compare different things, which is why we use percentages. So first challenge, let's convert these into decimals. Awesome. So hopefully remember the first one was just 0.9, 0.25, 0.17, and we're just shifting across 2 to the left. 29 is 0.29, 8% is 0.08, 100% is 1, 10.5 is 0.105, 1.4, and then 1.134. Cool. So to jump into this part here, when we increase a percent, it's easy to increase a percent by adding 100% to it. Now, what I mean by that is if you had a paint bucket and we wanted to increase this paint bucket, which has got 8 liters of paint inside of it, by 25%, it's going to get more paint inside of it, isn't it? So the old way that we would normally do this is work out what 25% of 8 liters is, which is 2 liters, and then we would add that on, right? So we would have the 8 liters, we'd work out the 25%, and then we add that 25% onto that one paint bucket. Now, there's a faster way of doing this, which we sort of touched on when we did GST, which is a little bit better. If we think about it, the 8 liters represents 100% of the paint. So this represents one of the paint cans. We're then going to add to that paint can 25%. So as a percentage, this final amount, what would it be? And hopefully you've worked out that you're increasing by 25%. So this final amount is going to be 125% of the original amount. Now, hopefully you've worked out the keywords here. 125% of means multiply, and all we would have to do is 1.25 times the 8. So let's use this easier way. If we increase 8 liters by 25%, we simply add the percentages together. So the original amount, which is 100%, plus the 25% to get the 125%. We then multiply 8 by 1.25, and then we get our 10 liters. So have a go at these ones. So the first one, 42, and we're not just times it by 0.9, we're times it by 1.9 because we're increasing it by 90%, and we get 79.8. We increase 60 by 25%, so we times it by 1.25, and we get 75. We increase 100 by 17%, and we get 117. 59 by 29%, and we get 76.11. 70 by 8%, so we times by 1.08, we get 75.6. 67.2 by 2, because it's going to be 100%, you get 134.4. 81 by 10.5, and you get 89.505. 328 by 2.4, which gives us 459.2. Our last one, we times it by 1.134, and we get 914.13. So hopefully we've worked out the hack there, and it makes it a lot easier. So when we decrease percent, it's easier by using the same technique, but instead of adding to the 100%, we minus from 100%. So if we reduce an 8-liter paint can by 25%, you do 25% of 8 liters, you get 2 liters, and then you would subtract it. But hopefully, if you've picked up, there's a faster way that you can do this. So the faster way, if we had 100% and we're taking away 25% as a percentage of the original can, how much would you have left? And hopefully you've worked out, you just subtract the percentages and you just left 75% from that 100%. So the faster way here, we did 8 liters. First, we work 100%, take away 25%, which gives us 75%. And then we do 8 liters times the 0.75, and we get our 6, which is just a little bit faster than finding the percentage out first and then subtracting it. Now, this might look a bit easier to you, and I've made it so that the numbers are a bit simpler. That's intentional so that you can see that. Always using percent is going to be a lot easier when we do different things. So a trick that we used to do when I was in sales many years ago, a lot of people would work out a discount for a customer by taking 10% away from the item. Now, that would involve them working out what 10% was, writing that down, and then in their calculator, they would do the original amount minus that. Now, that was a bit tricky because that would extend the time, take a little bit longer, and it's not just wasn't efficient. So instead, what worked out is by doing 1 minus the percentage amount, which in this case was 10%. So you get 90% of the original amount. You just times by 0.9. So whatever the price was, so for the $1,000 laptop, you do 1,000 times 0.9, bam, there was the final answer. And you didn't have to write down anything. So a lot of my friends were really happy once they worked this out. So a little bit of explore, just pause the video, have a go at that. So for the first one, we're decreasing by 90%. So we're timesing it by 0.1. So 42 times 0.1. So if we decrease $42 by 90%, you'd be left with $4.20. By 25%, we're going to times by 0.75 to give 45. 100 by 0.87, which gives us 87. 59 times 0.71, which gives us 46.61. 70 times 0.92, which gives us 64.4, 67.2 times 0, because if we're decreasing it by 100%, we're just getting rid of it, so there's nothing left. 81 times 0.895 gives us 72.495, 328 times 0.1736, which gives us 56.9408, and then 432.54 times 0.6232, which gives us 261.558928. Now, this is a really handy trick drawing a table up like this if you're trying to do problem-solving questions. So what I do is I'd have the original price, the sales price, and then the increase and decrease in between them. Now, the original price as a percent is always 100%. That never changes. But then the increase and decrease can be either a positive or a negative amount. And then the sales price is either going to be 100% plus that or 100% minus that as a percent. Now, this gives us a really cool reference tool. And then if we want to go down different rows, all we've got to do is use the original price times this amount, or we can use the sales price divided by this amount, and then we can go back to what it was. This will make a bit more sense when we do a question. So when we hear the word markup, it means an increase in percent. So if I had a $500 printer to sell and I needed to make an 80% commission on it, what would we do? The old way, we'd do 80% of 500, do 0.8 times 500, get 400, and then the sales price would be $500 plus $400 to give us the 900. Now that we've got the smarter way of doing it, we would do 100% plus 80%, which will give us 1.8. So 1.8 times 500, and that also gives us the 900. So it's a little bit faster. With discounts is when money's taken off an amount. So if you hear a 20% discount on a cable worth $10, The old way would be to find 20% of $10, and this works perfectly fine if that's the way that you want to do it, and you get your $2. But then the sales price at the end would be $8. So you do 10 and take away the 2. The faster way is you do 100% take away the 20%. So you times 0.8 by 10, and you get your $8 as well. So just pause the video and have a go and try and work out all the different discounts, sales price, and then an interesting column at the end, the sales price divided by the cost price. Cool. So for the first one, the sales price, the discount's $200. The sales price then is $1,800. And then the sales price divided by the cost price, see how that gives us the 0.9 or the 90%? Interesting. Then the next one, the television, is $150, $1,500, and then the $3,500, and then that gives us a 70%. And then 100, 150, and then 60%, 255, 1,445, and then we get 85%. 116, we get $1,334, or 92%. We get $12.50, so $487.50, or 90.975. 74.25, which gives us 24.75, or 25%. So this is the little trick that I use sometimes, is filling in the blanks with this. So if you ever have a function with two variables that are multiplied by each other, this triangle works all the time. Now, originally, I usually use this with speed. So speed equals distance over time, and you can fill in the blanks. But in this case, we can put the discount up the top here, and discount equals the original price times the discounted price. So this gives us a useful tool if we want to work out what we need to divide or times together. So if I want to work out the discount as a percent, I do the discounted dollar value divided by the original price. If I want to work out the original price, I do the discount divided by the discounted percent. And then if I want to work out the discount, I can do the original price times the discounted percent. So if I have this example with 20%, a 30% discount on a World of Warcraft game card, and he sold it for $28, and I wanted to work backwards and work out what the original price was, pretty much we need to just to fill in this blank. So we've got the sales price is equal to 100% minus the discounted percent times the original price. So if we go $28 is equal to 70% of the original price, we've got this really neat little function. Now to work backwards here, the original price, if we use the triangle glory here, and we fill in the blanks, the sales price there, the 100% minus the discount percent, and then the original price. If I want to work out that original price, see how it's just the sales price divided by that 70%, or the 100% minus the discount percent. So if we've got the $28, the 0.7, we just substitute that into the triangle. So $28 divided by 0.7, and you get the $40. So you paid $40. So just pause the video, have a go at this problem-solving question. So Daniel needs to make his $7,000 a week budget. He sold $6,257.40 this week, and it's $4.45 on Friday with his last customer. On how much percent markup does he need to do with a $4,000 computer if he makes 15% commission on his sales and wants to make budget? So he's got a budget of $7,000. If he sold $6,257.40, he needs to make a certain amount to make it. So first off, we've got to work out how much is he short. So if we do the $7,000 minus the $6,257.40, you get the $742.60. How much does he have to sell then? Well, his commission is equal to his commission rate times the sale. So his commission, we need it to be $742.60, and that equals 15% of the sale. So we're going to see $742.60 time is equal to 0.15 times the sale. So then we can swap this around. So the sale equals $742.60 divided by 0.15. So he has to sell this computer for $4,950.67. So how much of a percent markup does he have to do to the $4,000 computer? Well, first of all, we've then got to work out how much extra does he have to charge. So we can work out the sales price as a percent is equal to $4,950.67 divided by 4,000. and we get 1.2376. So then the profit as a percentage is equal to the sales price as a percentage minus 1, which then gives us 0.2376. So he would need to sell the computer for $23.76% in order to make that budget. Cool. So there is a Dr. Frost attached to that. The biggest trick with these type of questions is to do as many as you can. The more you practice, the better you'll get. And there will be a problem-solving question sheet that I'll be handing out to try and give a bit more practice with this space. So that's it from me. Hopefully you've worked out the difference between percentage increase and decrease. So with the increase, you add the percentage to 100%, whereas with the decrease, we subtract it from the 100%. Then drawing that table out with the cost price, the increase, decrease, and then the sales price, and then having the dollar amount and then the percentage really helps when you're trying to do a few problem-solving questions. That's it from me from Steam with Steve. If you did enjoy this video, please do give us a like and subscribe, as it does help with that YouTube algorithm, and also enable those notifications so you can see when new content gets released. Thanks again, and see you next time on Steam It with Steve. Adios.